This is a very special episode of Cycles TV. Today we will dive into the details of global weather and climate events. And if we think about, hey, we have the best available technology to detect cycles, why not apply that technology towards effects in global weather? And if we are able to uncover cyclic persistence in global weather or climate events. If that's the case, then let's invite another full section of scientific researchers to apply cycle analysis to weather or climate datasets. So that's the topic for today. Join me, and I will promise I will also make a link to business and economic relevant topics out of that data. So stay tuned.
From the mind of Lars von Tienen, the most advanced cycle analysis, hot off the press.
Thanks for joining us today on Cycles TV. We are the foundation for the study of cycles, and we will analyze a time series data set with our specific dynamic cycle analysis methods, mainly to learn to understand the way how cycles work in different data series and what to make out of that in terms of prediction forecasting. So that's why we're here once a week. So as I mentioned in the intro, today I will use a very specific data series based on global weather effects. And in specific, that data series is the El Nino sea surface temperature and the anomalies we see against the sea surface temperature at that region. You might ask why, because that is the region on Earth in the Southern Ocean where the temperature of the sea level has one of the most important influences on our global weather and the impacts around these weather effects. So let's start with the first primer on why this is important. Let's go step by step to really understand what we are doing here. So the main purpose right at the top is the idea if we can identify persistent cycles in the variability of climate global weather dynamics. And that's to be verified, but that's what we want to testify today. By doing that, we will use the sea surface temperature anomaly, which is one of the most important indicators in deriving effects, impacts, forecasts in terms of global weather events. So the El Nino Southern Oscillation, also called as ANSO indicator, which is quite one of the most important monitored time series out there. So that series, or the El Nino Southern Ocean anomalies, strongly influence global weather and climate, and that data series acts as one of the main inputs for climate forecasts. So we should then also use that available data not to make climate forecast, but maybe to analyze, is there a cyclic behavior within that series, which we can use then to apply dynamic cycle forecasting? And maybe that science will help out there from a cyclic perspective to understand those effects. And it's not just linked to weather. That's what I wanted to introduce. These days, commodity traders monitor the El Nino effects very closely and use this to base hedging technologies or hedging strategies based on their commodity trading. And there are a lot of companies in that area, insurance companies, energy companies, logistic companies, which are integrating that series and forecasting of that series into their risk management. So this is really climate changes on climate events which have a big business impact on the economic scale. And even the World Bank estimates that the El Nino impact can trim about to half to 1% of global GDP. So we have a huge impact here on not just climate events and also on the impacts on business and economic consequences out of that. And as mentioned, there's also these days commodity hedging around those data sets. So yes, there is a big impact on those global climate series. So as we are here as the foundation for the study of cycles, I mean, it's just a must. It's a must for us, yeah, to get that data, bring it into our cycle analysis technology, and see what we can get out of that, right? And maybe we can help, we can improve, we can add another layer of knowledge of analyzing that global weather effects and help others out there which rely on that information, right? So that's what we will do live now in this session. So what is the data about? The data looks like this. So this is the how the basic series looks like. So the sea surface temperature. Do you see the browser here? So the sea surface temperature anomaly in the Nino 3.4 region. That's the region we are talking about. So the Southern Ocean, and we are measuring the temperature deviation from normal conditions. Yeah, so the zero line is the standard or the normal conditions based on 23, 30 years of observations. That's the zero line, and we measure the deviation against those normal conditions to the upside or to the downside of the sea surface temperature level. Okay, so that's the simple explanation about what that data series is about. And I mean, I think you are aware of now that the huge deviations to the upside or to the downsides, these are the areas or windows in time when those big impacts, yeah, to the economy, to commodities, to storms, hurricanes, flooding, will be observed on our global planet here. So, I mean, measuring is always after the fact. But if we can predict, if we can forecast when we would expect those anomalies, I mean, this is what we are all trying to achieve, even in the research of the changes of global weather and the El Nino impacts. So we have that data series. We can use that data series. For sure, we will work with that data series. I mean, I need to complain. It's not easy to get the latest data. The US played an important role in providing the latest data series, and unfortunately, due to a lot of reasons, they stopped updating these data series. So, I mean, we have other sources for that, but it's a first topic. You need to find a reliable source providing the data set, and mainly it's monthly series. So this is where all the research starts out there. So you will find different data sources providing that data series where you can download that data public. So it's not hidden. It's available for us all to do further research. I've just done the same and then uploaded this into our cycle analyzer. So let's directly jump now into our dynamic time cycle analysis. Here I will open the screen. So this is the same series you've just seen as from the screenshot of the website, now uploaded into our cycle analyzer, right? So that's the same time series here, going from 1993 up to 2023. I don't care that we don't have the latest data because I will use this as a real-time example. Let's try to forecast 2024 up to 2025. I mean, because I've not found that latest data, at least not to download that data. The public data ends somewhere end of 2023. But as said, I just want to verify if I'm able to successfully find cycles in that data set. So we are not here now to do a real-time forecast on that. I found another website which provides the up-to-date data series, and we can compare later if we would be able to predict the data series based on our cycle analysis. Now we will apply to this series. First, what have I done to prepare the analysis? As I said, it's just monthly data. So for our dynamic time cycle analysis, it would be more helpful in having more granular data points, not monthly, maybe weekly, maybe daily. I mean, we don't get that, but we can do some oversampling. Yeah, so we will just interpolate the data as we have monthly. Yeah, we can interpolate even daily or weekly points in between. It doesn't matter because there's no real big deviation. It just gives us, like oversampling is doing, more data points to run some cycle analysis. So this is what I've done before. I've applied some oversampling to interpolate during the months, which gives us more granular data points, at least running daily, weekly cycle analysis on that. So, and as you've seen here, so I have now, let's resample these to the original. I've oversampled this to daily data, providing now, I think, 11,000 data points. It's the same period, yeah, just more in between. And I will now, what I will first do, I will aggregate this to, or resample this into a weekly data series. I mean, don't get too confused about that. It's completely the same data series. It looks the same, no change at all. It's just that you be a little bit aware of, you need to apply pre-processing on that kind of data set before you jump onto this type of analysis. Okay, so we have it now at our fingertips. I will use weekly data. We have 1,500 data points, which is exactly in that range I would like to have for an updated data set. And I mean, now that's the beauty. What happens? We have our state-of-the-art cycle analysis technology at our fingertips, and it shows us the spectrum at the bottom. So we see, so there are some clear cycles which can be identified, weekly cycles, in the anomaly surface temperature in the Southern Ocean, the El Nino data series. So yes, there are cycles. They are very evident in the spectrum just by first visual observation. And you know that we have the best indicators available now to apply also some more statistical verification of those cycles. So if we have a joint view here, what we see in addition to the length of those cycles, I mean, most cycle analysis try to identify just the pure length. So if you do some research on scientific papers which are analyzing cycles in that data series, they mostly refer to analyzing a common length in those cycles, which is one part of cycle analysis. I agree, getting the length of a cycle, but just ending with the conclusion of a very complicated research paper that yes, there is a yearly cycle of 2, 3, or 4 years in the data series, according to their analysis, with lots of research done. I mean, for today's state-of-the-art cycle analysis, that's just the first step. I mean, coming to the conclusion that there's a common cycle with a common length is the most basic part of the cycle analysis. And to be honest, this helps us nothing in terms of trying to forecast that cycle because we don't know the phase. We don't know the status quo of that cycle. Just the length information is not enough. So not complaining with that research, but we have even better tools, not just detecting the length of a recurring cycle in the data series. We can also now precisely analyze what is the phase, what is the status quo of that specific cycle now time, today, which is one of the most important parts of cycle analysis before doing a projection or forecast of that cycle length, right? So let's get back to the data series. So we have the data series, the spectrum, the peaks in that series clearly indicate what cycles are dominant, and we have even better information here about the stability of those cycles. You might be aware that a cycle should only be used for forecasting or projection if it has been very stable in the past. And stable means the length has not altered too often, so the cycle has been close to that length and is not jumping around. And second, also the phase. Yeah? So where that cycle is looping almost perfectly against the sine wave. So that would be a perfect phase alignment of that cycle. I mean, reality is never perfect, but we can measure how stable that real cyclic behavior can be measured against the theoretical sine wave. Yeah? And that's the kind of stability we can then bring into a mathematical term. And this is what the stability will do. And you must have, or you should have, a stability score above 0.5. If you have a stability score below 0.5, this means yes, that cyclic length is dominant and somewhere available in the data series, but it does not seem to be stable over time. So it very often changes the length, phase, or amplitude, or a combination of all three aspects during time, which makes it still valid to detect it after the fact. But if you have that high variability, it makes it more or less useless to do any projection. So you always should look for cycles with a stability above 0.5. And we can see here in our analysis, we have 3 cycles which qualify not only to be valid cycles with a given length here, they also qualify in terms of stability. All the other cycles, which could maybe visually be seen in the spectrum, so that's also another parameter we provide here at the foundation, not just the visual shape, the stability. And yeah, long story now, coming to the conclusion is, we can conclude we have 3 valid cycles with a given length, which have enough stability, low variability in the past, which qualify to be selected for projection and forecasting. And the color coding shows us, which I mentioned, we also are aware of the current phase where that specific cycle is in its status quo, right? So that's what we get just with a blink of an eye with our cycles technology. I mean, this can really, maybe a final comment, this can really shorten your analysis time as a researcher. Before, you needed to apply a lot of time, a lot of dedication in doing that kind of analysis. With our tools here, we really would help to speed up that analysis mechanism. Yeah, it's just there. You can concentrate on the impact on the effects, and all the required features, variability, stability, ranking, length, phase, is all given right away from the analyzer. Okay, long story short, I think now we understand we have cycles, we can detect them. So there is a rhythm in the anomalies in the sea surface temperature. We know the phase and we know now which one to select. So let's now just pick those 3 cycles, right? You now have the understanding why. So applying those 3 cycles here now to that data series, as a first visual check, allows us, and the purple plot now is the dominant cyclic composite analysis based on 3 cycles. And as you can see, it wraps the real data almost perfect. So by using 3 cycles, or by only using 3 cycles, we could explain almost all anomalies in the past of that data series, which is quite interesting. So I think it's not random effects which cause those anomalies, these temperature changes, compared to the base observation or normal conditions. There seems to be really dominant, persistent cycles behind those temperature changes, which are mainly driving those changes, not just random events. So that's number one. I would argue cyclic effects are the most important ones to El Nino surface temperature anomalies. Number one. I mean, it's a tough statement, but I'm just looking at data, nothing more, nothing less. Second, now let's have a look how good or bad, this analysis is looking into the future. As I said, the good or the bad part of that data series I found is just it ended December 2023. Yeah. So now this is how your forecast would have looked at the end of 2023. Yeah, it's exactly the picture we would have received by end of 2023. So the projection, let's now have an interpretation of the projection we're seeing here. So we are increasing, we are already, so as you know, you need to monitor above the 0 level. Yeah, so that's the baseline here where the 0 is. Let's add this just as another line here. So we have strongly pushed up, and from the cyclic projection, we expect to be close at a peak of the positive deviation from normal conditions. Yeah, from a time perspective, we are close to peaking, reaching the highest point of the deviation of that anomaly, and then by 2024, we are expected to move down. So the upside deviation should really calm down, should become lower, and get back to normal conditions. I mean, we don't know the amplitude. Yeah, we just can predict here that the peak should be close in front of us, and then the anomaly is expected to go down back to normal conditions again after that point in time, and then moving, I mean, we don't know, into a low point, maybe early 2026, but we should anyhow not predict further into the future than the next 1 or 2 turning points of that cycle here. So that's our forecast, right? So let's have a look at the real data. So what did happen to the El Nino sea surface temperature deviations from normal conditions? So I found another data series. Yeah, here it is. I need to zoom in. So this is one data series. I need to zoom in a little bit. So here we have it. Right. So here we have at least a picture which shows us the data until now. So October 2025. I don't have better data, but you see here it's peaking early 2024, and then all the way 2024 coming down to normal conditions, and then all the way 2025 reaching a low here and then keeping at that lower level. So if we would transform, expecting a top 2024 and then coming back to normal levels into 2025, I mean, this is the real data, which I'm showing here. Let's now switch back to our forecast. Our forecast predicted coming into a top early 2024, and then coming at least sharply coming down into normal conditions here early 2025. So what happened in the real data, I will just put it in, quickly after that point when we did our forecast here, we reached our top beginning 2024. Then the data series came down around to the 0 level here beginning 2025, and then now is hovering here around the 0 level. So the red line is what happened after the fact. And we are now at this point in time here close to, we are close to end of 2025. At this point here now, maybe expecting maybe another deviation to the upside, but we should update the data series and update our cycle analysis. But the point I want to make here at this point is that this projection was spot on just by using 3 cycles and our cycle analyzer technique, right? So, I mean, this is not perfect. And I mean, we cannot predict it right on time. But I think just showcasing that quick exercise and that quick study, which I just have run here in 10-15 minutes, shows us the power of cycle analysis can be used also to predict those climate events. Yeah, here based on the El Nino sea surface temperature anomalies. And yes, that forecast was spot on to predict the top in 2024 and then the down move, which happened right on time back to normal levels. And now let's see if we can see another upswing in that series. And I mean, you have seen the introduction. This has a huge impact on a lot of economic related series here: commodity trading, flooding, critical impacts to different commodities, not just for trading, sondern for real environment, which we need here living on this planet. So that's important. That's just the point I want to make. And if I look at the current research in that area, I think the cycle analysis just provided here can help a lot, can really help a lot to speed up the existing analysis. And I think more focus on cyclic behavior, on daily and weekly timeframes can really, really help to improve that body of knowledge, which is important for us all here living on that planet, and providing some tools to speed up the research in that area is, I think, helpful for us all. Whatever specific area then afterwards you are looking into, or being it business, being it economic, or being it a global weather or climate related impacts, that's a huge benefit. Thank you for joining me today. I hope I inspired you a little bit to also use the cycle analysis tool from different perspective. Yeah, and those global perspective can really make a difference moving forward in terms of cycle analysis. So please leave a comment here if you like that kind of content, also focusing on different time series analysis to provide here, and maybe what you would like to see as additional topics. Or I would also be interested in research papers which you might know and I have not been aware of. So do us a favor, put them in the discussion below the video. That would help us all to improve that research. Thanks for joining me today for that 30 minutes. I really enjoyed showing and sharing those analyses with you. And please try to give me a lot of comments. See you soon. Thank you.